Hello everyone, welcome to this video on learning mathematics through concepts and examples. Today we are working on mastery exercise 5 from your intro to statistics class. Let's begin with our first example. So first example says, determine whether this table represents a probability distribution. So you can see we have the random variable x and the probabilities. Now for this type of distribution to be probability distribution, it has to satisfy two important conditions. And the first one is, okay, let's see, let me write it down. The first one is all these probabilities must be between 0 and 1. So if you look at all these values, 0.25, 0.1, 0.2, 0.4, all these probabilities are between 0 and 1. So all probabilities P of x, they are between 0 and 1. So that means the first condition is true. Now we need to look at the second one. That is, we need to find the sum of all these. So if we try to find the sum of all probabilities, which is 0.25 plus 0.1 plus 0.2 plus 0.4. Okay, if we add all these 0.25, 0.1, 0.2, 0.4, you can see 0.4 plus 0.2 is 0.6, 0.6 plus 1, I mean 0.1, that is 0.7 plus 0.25 is 0.95. So this is equal to 0.95, which is not equal to 1. That means the second condition is not true. It has to be 1 for this distribution to be probability distribution. So meaning of that is this is not a probability distribution. So our final answer will be, so it is not a probability distribution. It is not a probability distribution. Okay, that's example 1. Here is our example 2. Find the mean of this probability distribution. Round your answer to 1 decimal place. So if you remember the formula for the mean of the probability distribution, mean mu is the sum of x times p of x. So we need to find the sum of x times p of x. So let's find out how we can find that for this one. So here mean is the sum of x times p of x. So we have to find the product, okay? We have to find the product and add them together. So the first one is 0 times 0.15, 0 times 0.15. That is the first one, plus the second one is 1 times 0.2, 1 times 0.2. Then plus the third one will be 2 times 0.1, 2 times 0.1. Then plus the next one is 3 times 0.55, 3 times 0.55. And if we simplify all these, okay, you can use calculator to simplify this, you'll get 2.1. So mean of this probability distribution that is given here is 2.1. Remember the formula for the mean is x times p of x. Sometimes the mean of the probability distribution is also referred as the expected value or expectation. Time for example 3. Find the standard deviation of this probability distribution. So here we are looking for the standard deviation. So standard deviation for the discrete probability distribution denoted by sigma is the sum of x minus the mean squared times p of x. So as you can see here, we need the value of mean first. Mean is the product of x times p of x, the way we did here in the second one, x times p of x. So let's begin with the given values, x, p of x. Okay. So we have the given x values. and the x values are 0, 1, 2, 3. These are the x values. The probability values are p of x is 0.1, 0.05, again 0.05, and then 0.8. So these are the probability values. Now here, to find the mean mu, we need x times p of x. We'll find that x multiplied to p of x. 0 multiplied to 0.01, that's a 0. 1 multiplied to 0.05 is 0.05. And then 2 times 0.05 is 0.10. And then 3 multiplied to 0.8 is 2.4. That is 2.4. Now we can add those values. Let me decorate this table a little bit. Okay. There we go. We find the total now. And here, if we add all this, it will be 1, but we don't need to add that. But we need to add this one, x times p of x. If we add all these, the sum of x times p of x is our mean, which will be equal to 0 plus 0.05 plus 1.0, 0.10, and then 2 plus 2.4. So if we add all that, it will be 2.25. 2.25. So we got the mean. So in next column, we need to find this one. We need to find, let me write it down. We need to find x minus mean. Mean is 2.25. And then square that. Okay, square that and multiply with p of x. So what I mean by that is, for example, in the first one, in place of x, we plug in 0. 0 minus 2.25 squared times p of x. P of x is 0.1. If we do that, we get 0.6530. Similarly, next one, we need to plug in x equal to 1. So we plug in 1 minus 2.25 squared. Multiplied with that probability, it will be 0.1201. If we plug in 2 again, so if we plug in 2, 2 minus 2.25 squared, multiplied to this probability, 0.05, you will get 0.0151. And finally, we plug in 3. So 3 minus 2.25 squared multiplied to 0.8 is 0.1620. And then if we add all these numbers, we get 0.9475. So now we can write our final answer, or we can find our final answer. Hence, the standard deviation is the square root of the sum of all these values, which is 0.9475. So square root of 0.9475. And that is equal to, if we take the square root, it is 0.9734. So the standard deviation for the probability distribution that is given here is 0.9734. So that is the basic idea with the probability distribution. So first thing we need to know in probability distribution is to check whether it's a probability distribution or not. For that, all probabilities must be between 0 and 1, and sum of all probabilities must be 1. In this case, the first condition is true, second condition is not true, so this is not the probability distribution. In second example, if this is the probability distribution, we are asked to find the mean. Mean is the sum of x times p of x. So x and p of x, we multiply them, and then we add them together. That's how we can find the mean. And for standard deviation, we use this formula with the square root, in fact. Okay, so here should be the square root for that. In fact, the quantity inside the square root is the variance. So when you have this one, all you need to do is we need to find the sum of x times mean square times p of x. Take the square root the way we did here to get the standard deviation, because That is a formula for the standard deviation. So these are some of the basic ideas that we need to know while working on the discrete probability distribution. So based on that, let's work on a few more problems related to this. So example 4, can the table be probability distribution? So here is the table again, and we need to check whether this is a probability distribution or not. So we need to check whether those two conditions are true. For the table, for this one to be probability distribution, both conditions must be true. If one of them is not true, then it's not a probability distribution. The first condition is all probabilities must be between 0 and 1. But if you look here, probability when x equal to 1, probability when x is equal to 1 is this one here, which is a negative 0.5433. This is negative. Okay, this is negative. This is negative. Probability cannot be negative. Okay, probability cannot be negative. So meaning of that is this one is not a probability distribution. So this implies this is not, or the given table is not a probability distribution. Is not a probability distribution. Because one of the probabilities is negative. Probability cannot be negative. Probability is always a value between 0 and 1, but this is less than 0. So this is not the probability distribution. Okay. Next problem here. Find the mean of the following probability distribution. So like in one of the examples we did before, we know the formula for mean. We know mean denoted by mu is the sum of x times p of x. So you can see they have given x, and here we have p of x. So we multiply and add. So first one is 0 multiplied to that. So we write 0 times 0.2558. That is the first one. Then plus the second one is 1 multiplied to that quantity. So 1 times 0.0475. And then plus the next one is 2 times that quantity. 2 times 0.2971. So we will continue to multiply like this. Next one is 3 times that. So plus 3 times 0.1475. And finally, the last one, which is 4 times that. 4 times 0.2521. 2521. And now we can simplify all this using calculator. And if we do that, we'll get 2.0296. So that is the mean. Okay, 2.0296. That is the mean for this probability distribution. Remember, while calculating the mean, we use the formula mean is equal to sum of x times p of x. So that is the important formula that we need to know and we need to apply while calculating the mean of the probability distribution. Next one now, number 6 here. Consider the discrete random variable x. So here is our discrete random variable x given in the table. We are asked to calculate the mean, variance, and standard deviation. Okay, we are calculating the 3 different things. So what we'll do is we'll start by making the table. So let's see, we have the x values given. X values are 8, 10, 12, 13, 14, 15, and 16. These are the x values. Now p of x is also given. P of x 0.12, 0.14, 0.25, 0.13, again 0.13, then 0.12, and 0.11. Okay, these are the values. Now the first thing we want here is the mean. Okay, the first thing we want is the mean. So the first thing is the mean, denoted by mu, is the sum of x times p of x. So here we have x, here we have p of x. So we need to find x times p of x and add them together. So let's do that. So in next column, we need x times p of x. So now the first one is 8 multiplied to 0.12, which is 0.96. Next one is 10 multiplied to 0.14, which is 1.4. And the next one is 12 multiplied to 0.25, which is a 3. And then 13 multiplied to 0.13, which is 1.69. 14 multiplied to 0.13 is 1.82. 1.82. 15 multiplied to 0.12 is 1.8. And finally, 16 multiplied to 0.11 is 1.76. Okay. So let's see what we are getting here. Let's find the total. If you add all these probabilities, that will be 1, but you don't need to add. But here we are adding this because sum of x times p of x is our mean. So 0.96 plus 1.4 plus 3 plus 1.69 plus 1.82 plus 1.8 plus 1.76, that is mean is equal to 12.43. 12.43. So if we add all this, we get the mean, that is 12.43. So we can write here, this is equal to 12.43. Now, the next thing we want to find is the variance. So if we remember the formula for variance, variance is the square of the standard deviation given by the formula sum of x minus mean quantity squared multiplied to p of x. So here in next column in our table, we need x minus the mean. Mean is 12.43. 12.43 squared multiplied to p of x. And if we find all these values and add them together, that will be our variance. So here what you have to do is, first we need to plug in 8. So it will be 8 minus 12.43 quantity squared multiplied to p of x. P of x is 0.12. So if we do that, we get 2.355. Make sure you check this in your calculator. Similarly, if you plug in 10, it will be 10 minus 12.43 squared multiplied with the probability, which is 0.14, and you'll get 0.8267. Next, for x, we plug in 12, and for probability, we plug in 0.25. And if we simplify that, we'll get 0.0462. Similarly, if we continue, next value we'll get is 0.0422. Next one we'll get 0.3204. The second last value will be 0.7926. And finally, the last one will be 1.4019. And now we can add all these values, and that will be our variance. So if we add that, we get variance equal to 5.7851. 7851. If we add all these numbers, okay? If we add all these numbers, we'll get 5.7851. So meaning of that is the value of the variance. This is equal to 5.7851. So the third one is the standard deviation, which is the square root of the variance. So it's square root of 5.7851. And if we simplify this using calculator, it will be 2.4052. So that's how we can find the variance. And then from variance, we can find the standard deviation. So in this problem, we learned how to find the mean, variance, and the standard deviation of the discrete probability distribution, which is given. We have to be very careful when we find these values, because while finding these values, we are plugging in the value of x and p of x from here. Okay, these are the x values, these are the p of x values. We are typing them in calculator and we are getting these values. So you have to be very, very careful when you execute that calculation. Example 7. If a seed is planted, it has 60% chance of growing into a healthy plant. If 11 seeds are planted, what is the probability that exactly 2 don't grow? So this question has a little different thing given here. You can see here we are talking about 60% chance of growing. And when we go here, we are talking about the probability of exactly two of them don't grow. So we are looking for the probability that 2 of them don't grow. So to begin with, we begin here where it says it has 60% chance of growing. So 60% chance of growing, meaning of that is probability that it won't grow is 40% or 0.4. We want the probability of not growing because here we are looking for the probability of not growing. So P is 0.4 and Q will be 60% or 0.6. That is the probability of growing. So here probability of not growing is your P. If 11 seeds are planted, so that's the value of N. You can see 11 seeds are planted. So N equal to 11. We have to find the probability that exactly 2 of them don't grow. So X is equal to 2. So 2 of them don't grow, meaning of that is X is equal to 2. So once we have this fundamental idea, what we know is if you plant a seed, it will either grow or it will not grow. Only 2 chances or only 2 outcomes. And probability of not growing is 4. And probability that it grows is 0.6. That's also fixed for each number of seeds we have. And the number of trials or N is fixed. Meaning of that is this is the binomial experiment and we can use binomial probability distribution. And this is what we know for binomial probability distribution. We know probability that probability of X successes out of N is equal to N factorial divided by X factorial and also N minus X factorial in the denominator multiplied to P to the X multiplied to Q to the N minus X. So let's plug in the values. N is 11, so it is 11 factorial divided by X factorial. X is 2, so 2 factorial. And then N minus X, that will be N minus X, it will be 11 minus 2, which is 9 factorial, times P is 0.4. 0.4 raised to X is 2, times Q is 0.6, raised to N minus X is a 9. Now here, if you have seen this factorial for the first time, when we say factorial, for example, here when we say 2 factorial, meaning of that is 2 times 1. When I say 9 factorial, it is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Similarly, 11 factorial, you start with 11. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And in order to simplify this using calculator, like if you want to evaluate 11 factorial in calculator, in your TI-84 calculator, let me quickly write down some steps for you. Say, for example, to find 11 factorial in your calculator, what you'll do is you'll first press, okay, these are the steps that you need to follow. You go, first you type 11 on the screen. First you'll type 11, and then you'll go to math, and then you go to probability. Okay, you go to probability, and then you go to number 4. After that, you go to number 4. Okay, so this is how you'll be able to type back factorial. So if you do all this in your TI-84 calculator, you'll see 11 factorial on your screen. So you can try that. So if you follow the same process, once you type 11 factorial, then you can use divide and then type 2 factorial and then 9 factorial and multiply that by 0.4 squared and 0.6 to the 9 and simplify that. You should get 0.0887. So that is the probability that exactly 2 of them don't grow. So always remember, whenever we are working on the problem on binomial probability, we have to use the formula, which is something like this one here. Okay, let's move on to next example. Example 8, use binomial distribution n equal to 7, p equal to 0.7, and we have to find probability that x is equal to 6. So let's use the formula. So what we know is probability of x successes out of n trial is equal to n factorial over x factorial n minus x factorial multiplied to p to the x multiplied to q to the n minus x. Now plug in the values. N factorial, number of trial is 7. So this is 7 factorial divided by x is 6. So 6 factorial. N minus x will be 7 minus 6, which is 1 factorial. Multiplied to p is 0.7. Raised to x is 6. Multiplied to q, if p is 0.7 or 70%, q is 30% or 0.3. Raised to n minus x, which is 1. Okay, here also we have that n minus x, that's 1. So it's like 0.7 raised to 6 and 0.3 raised to 1. Now again, we can use calculator to simplify this. One more time, to get the factorial in your TI-84 calculator, you have to go to math, then probability, and number 4. So once you use your calculator and simplify this, you should get 0.2471. 0.2471. That is the probability that x is exactly equal to 6. Next example. A poll is given showing that 75% are in favor of new building project. If 8 people are chosen at random, what is the probability that exactly 3 of them favor the new building? So here what they are saying is 75% are in favor of new building project. So probability that they support the new project will be 0.75. So probability they are not in support will be 25% or 0.25. And here they're asking exactly 8 people. Exactly 8 people are asked. Meaning of that is n is equal to 8. Okay, out of these 8 people asked, what is the probability that exactly 3 of them favor the new building? We have to find the probability that exactly 3 of them favor the new building, meaning of that is x is equal to 3. So once we have all this information, now we can use the formula, as we know that this is binomial probability distribution. So probability of x successes in a binomial probability distribution is n factorial over x factorial n minus x factorial multiplied to p to the x multiplied to q to the n minus x, which is equal to n factorial. Your value of n is 8. So it is 8 factorial